Hello and welcome to another rendition of Math is Easy Step by Step. In these coming videos, I would like to go over each and every exponential rule and then go over and show examples relating to each of the rules. And so let's go ahead and just get started. One of the first things you need to know is that each term, whether it's a variable x, y, z, or a constant 3, 5, and 100, each one of these terms has what I call an invisible 1 in the exponents place, excuse me. Also, other than the consonants, 3, 5, and 100, and numbers like that, there'll be an invisible 1 in front of the variables, unless there's a number already assigned to the variables. And then in each of these terms, there's also an invisible 1 in the denominator. And many times, if you can show that invisible 1, it will eliminate a lot of the confusion associated with mathematics. So that's the first rule, number one, right off the bat. Hey, show those invisible ones, especially when it comes to the exponential powers. And each of these values, x, y, z, 3, all have an exponential power of 1. And that will help eliminate confusion if you can write those down. So at first, I like to go over the adding rules for exponents, and I will finish by going over the subtraction rules when adding and subtracting with exponential values. In the next video, I'd like to go over examples of both adding and subtracting so you could see these rules in action. So we got to keep in mind with the adding rules and subtracting rules, you must have the same base, x, y, z, 3. These are all considered the base. And then the same exponential power to the first power, invisible 1 first power, to the second power, the third power. So you have to have the same base, the same power, and those are called like terms. If you need to review like terms, I've uploaded a video on like and unlike terms. So please review that video, like and unlike terms. That will go over much more in depth and you'll have a better understanding. So in order to add or subtract with exponential values, you need to have like terms. So I'd like to give you a quick example here. And number one, again, the first thing you need to do, show those invisible ones. There's no number or coefficient assigned to this x variable, so I'm going to show the invisible 1. There's an invisible 1 in front of that x. And then, of course, no exponential value is assigned here to the x, so, but I'm going to show there's a 1. This is x to the first power. I'm going to show that invisible 1 plus coefficient of 2, x, and show that individual 1 base. Exponential power, excuse me. The base is x. The base is x. So now we've got x and x. We have the same base. We have to the first power, So since these are the same base with the same exponential powers, these are considered like terms. And all we're going to do is add the coefficient in the front of the x. 1 plus 2 equals 3. These x's are attached through multiplication, so we're going to keep that in our answer. You could write this answer as 3x or 3x, and you can even show that invisible 1, or you can just write a 1 here. They all mean the exact same thing. So hopefully that's helping out a little bit. Number 2. Let's take a look at example number 2. We have y to the third power plus 5y to the third power. Because this y to the third power has a coefficient of 5 attached to it, we don't need to put any invisible ones. The coefficient is 5. But you see this first y to the third power. There's no number in front of that y. So that means the coefficient is an invisible 1. Hey, put down that invisible 1. Show that invisible 1. That will help you to see, hey, that's 1y to the third power. And again, each of these y's has a power to the third power. Hey, these are like terms. Same base, y, and the same exponential power, 3. Now we can add or subtract these coefficients. What's 1 plus 5? 1 plus 5 is 6. And then y to the third power stays the same. It's attached to those coefficients through multiplication. So the answer here, 1y to the third power plus 5y to the third power is 6y to the third power. And finally, I got another third example here to show you. Number 3, 3 to the second power plus 3 to the second power. We have the bases are the same, 3 plus 3, and then the power is to the second power. They're the same. We can add these terms, 3 squared. So 3 plus 3 is 6, and when you're adding or subtracting, you keep that exponential power the same. Let's take a look at some of the subtraction rules that I have set up here. It's pretty much the same thing. And so I'll be going through this. If I go too fast, please pause, rewind, and watch again. So exponential rules. Third is subtraction rules. So the same rules as adding. You must have the same base and the same exponential power. That makes them like terms. So here are the four examples I would like to go over with you. In fact, my paper can stop jumping off of the table. Here we go. Example number 1. We have 2x to the third power minus 3x to the third power. We have the same base, x and x. We have the power of 3. These are like terms. I don't need to show any invisible ones here because I'm assigned a 2 and a 3. Hey, what's 2 minus 3? Negative 1. There's an invisible 1, so this is a negative 1, x. And then the powers stay the same, x to the power of 3. You could also write this just negative x to the third power, or negative 1. Right in that whole 1, x to the third power. All three mean exactly the same. Number 2, we have our bases are y, our exponential power. Show those invisible ones. We can see they're both to the first power. And 5 minus 2 is 3. Y. You could show a 1 in that exponential place, or you can show a dot, 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 invisible 1. All three answers would be exactly the same. Hey, let's take a look at problem number 3. We have 13 to the fifth power minus 18 to the fifth power. Coefficient, coefficient. Coefficient are the same, right? One coefficient with another coefficient to the power of 5 to the power of the 5. We can then subtract 13 minus a positive 18. Keep, change, change. I'll teach that rule or show that video in the future on integers. 13 minus 18 is a negative 5, right? If you have $13 and you owe somebody $18 and you give them that 13, how much more do you owe them? You owe them $5. That's a negative 5. You keep the powers the same. And finally, I'll be doing more examples in the next video of adding and subtracting with exponential powers. You can see here, I wanted to show you, we have 3x squared minus 5y cubed. Now, x and y are not the same. The bases are not the same. And then the exponents are not the same either. Those are not like terms. So you cannot add or subtract. All you can do is rewrite them in the problem or circle this answer. You've simplified this expression as far as you can. Hey, I hope you found this helpful. Math is easy, step by step.